Hi everyone, welcome back to Kelly's Data Insights. If you're new here, I'm Kelly. Stick around until the end of each video where I share a bit of motivation to inspire you along your journey. In today's video, we're covering a crucial step in data analysis, how to import Excel spreadsheets into Epi Info and analyzing data using classic analysis. Don't forget to like, subscribe, and click on the bell icon so you never miss a tutorial. Alright, so before we import our data from Excel to Epi Info, we need to make sure our Excel sheet is properly formatted so that Epi Info can read it. So these are the 4 things that you need to make sure. Number 1, column name. The first row should contain column names. Make sure that the column names don't contain spaces. For example, patient name should be patient name or patient name like this. Otherwise, Epi Info will not be able to read the data. So what we're saying about the first row is, as you can see here, from SN, which is the serial number, until date of visit, that is our first row, which has different columns. So when we're saying rows, we mean horizontally. And when we're talking about columns, we mean vertically. So these are our columns, and the ones that are going horizontally are our rows. So make sure that the first row does not contain spaces. As you can see here, height underscore centimeters. So that's why we used the separation. Just like when we did it in project name, when we're creating a form, we do not use spaces. We just use underscores for the separation, and we also don't use any numerics. Alright, so the second thing that you need to make sure is do not merge cells. This will confuse the system, which leads to Epi Info not being able to read the data. Alright, so as you can see here, L, the column L and M. If I were to highlight this section, and you can see here there's a section called merge and center. So if I were to select this, this will mean L and M become one. So we don't want that. So let me just quickly unmerge this. If you feel like the space in this column is not enough, what you can do is, as you can see here, go in between L and M, and you can see that cross. You can drag it or move it to your right, and if you feel like this is enough space, that's how you're able to create space for that specific column. As you can see here, I made space of 11.71. All right, so that's how you create space. If you feel like your information, your question, whether it's your question or your answers, you don't want it to be cropped up, you can make spaces in that sense and not merging the two cells. All right, so the third thing that you need to keep in mind is that do not use special characters. Special characters like hash or percentage. These are examples of special characters. Number 4, use standardization. You can use text-based standardization, which is your yes or no, or numeric standardization, which is your 1 or 0. This you can use in your Excel sheet before importing it into your Epi Info or into Epi Info. If you're using word standardization, which is your yes or no, make sure you use it consistently. If you start with yes or no, which is preferred, you should not use yes or no, which is capitalized, or yes or no, which is in lower cases. The preferred method of using standardization is yes or no in this format. And you need to make sure, as you can see here at night sweats, in this row, in this column, you can see that all of the yeses, the first letter in the word is capitalized and the rest is lower cases. We continued with the same method even here in the column of fever. You need to use the same way, so it needs to be consistent. Alright, so now we're going to look at how to save your Excel sheet to ensure that your data will import smoothly into Epi Info. Alright, so while most people recommend saving your Excel sheet data as a CSV file, since Epi Info works well with CSV, I've encountered challenges using this format. Instead, I recommend saving your file as Excel 97/2003 workbook, which is your XLS, which I found to be more compatible with Epi Info. But you can choose to save your data either as a CSV file or an Excel 97/2003 workbook, which is an XLS format or file, whichever works best for you. I personally find that Excel 97/2003 workbook to be more reliable. Alright, so then this is how we're able to save. First, you need to go to File, then we Save As, wherever you want to save it at. And then here it is. So this is my title, the file title. And then you can see here, you go to the drop down list. And as you can see here, there are different file types that you can save it as. There, you can select if you decide to save your file as a CSV, so comma delimited, you can select this and save it as that. But for me, I will be saving my file under Excel 97/2003 workbook. So that is what I will be saving it as. So you select that and you save. Alright, so now you can see that we're on the Epi Info interface. And since we're going to analyze our data using classic analysis, we first need to select classic analysis. Alright, so after this, you need to go on your left hand side and then you select under data, you select read. Alright, so here it will be, here it's written recent data sources. If you were working on a project or a file, your recent one you can select from here. And then underneath you can see that there is written database type. So here you can select, you can click on the drop down list, and then here you can select how you saved your Excel sheet. So if you saved it as a CSV file, you would select your CSV. And if you saved it as whichever file type you saved it as is what you'll use. Since I saved it as an XLS, I would select Microsoft Excel 97 2003 workbook. And then underneath here you see data source, and then you select browse. And then here now you can browse wherever you have saved your file. So I saved my file in documents, so this is the TB questionnaire example. So I just select that and I open and then press OK. Alright, so there you see under Data Source Explorer, TB questionnaire example, then you select it and then you press OK. Alright, so as you can see here, the current data source, this actually shows the location of where our Excel sheet or my Excel sheet is located. And then here it shows the record count, which is 10, and the date. And here you can see our command or whatever command we did. And here is also where our file is located. Alright, so but for analysis, we'll be focusing basically on the statistical analysis, which is located here. So we'll be going through some statistical analysis commands, with the first one being list. So we'll go to list. Alright, so you see that there is a section called variables. So, and then the first, if we go to the drop down list, you'll see the first one has a star, and that star, as we saw, represents all. So all our records or all our columns or information in or the data within each column will be represented here. So if we're supposed to select, if we just want specific variables to be shown on the list, say for example you just want age and you want gender, as well as, for example, height, and then you press OK, you'll see that there will be a list based on this information. All right, so the information on age, you can see all the records of age, and gender, all the records of gender, as well as height, all the records of height. But in this case, I just want to have all my records. So we go back to list and then we press all and we select all. All right, so there you see SN, which is the serial number, the age of all the records are there, gender as well as height, weight, smoker, night sweat, fever, as well as date of visit, and then the other four records which did not contain any data is present. All right. So for the next analysis command we'll be doing is frequency. So we click on frequency. All right. So for frequency is basically a command that we use for us to show how often something occurs. For example, if we go here, frequency of, you'll see the star representing all. If you want to see all of the frequencies of each variable, it will show. But if you just want to focus on a specific variable, you can select that variable. So for example, if I choose gender, I select gender and then I press OK. All right, you see that there's this table that shows the gender frequency. You see here under this column is female, male, and then the total. So we see that there's a total number of individuals is 10, and then for females is 4 individuals and 6 individuals for males, which comes into percentage wise is 40% for females and 60% males. So we have more males compared to females. All right. And then here we have a 95% of confidence limits. All right. So for example, if you want two variables, let's just go to frequency again. If you want the frequency of something, for example, let's go back with gender, and that is stratified by, for example, smoker. We select smoker and then we press OK. We see that the table is based on the frequency of individuals that selected no, that they don't smoke, and in that category 7 of them selected that they are not smokers. From the 7, 2 of them are females and 5 of them are males, which in turn comes with a percentage of 28.57% being females that do not smoke and 71.43% of males that do not smoke. But if we scroll down, we'll see there's another table here for smoker, which equates to yes. So that means the participant selected yes, they are smokers. And from the 3 that selected that they are smokers, 2 of them being female and 1 of them being a male. So we have 66.67% of females that are smokers and 33.33% which are not smokers under the males. So this shows that there are more females that smoke compared to the male population. All right. So the next thing that we'd want to focus on is tables. So we go to tables. So for table category, also known as cross tabulation, shows the relationship between 2 variables. All right. So for example, if we go to exposure variable and we select our variable, for example, gender. Let's use the same one, and the outcome variable, we select smoker. So we want to see the relationship between smokers and their gender. So we select OK. We select OK. All right. So then here you can see that there is a table. And in this table, you have the gender here. And then here you have the individuals that prompted yes or no. So here you have females. You have 2 females that selected no, that they are not smokers, and two females that selected yes, that they are smokers. So we have like a 50-50 percentage. So 50% of females that do not smoke and 50% of females that do smoke. And then here for males, we have 5 of them that are non-smokers and 1 of them that is a smoker out of the 6. So we can see here 28.57% of females do not smoke. And we have the males. Under the males, we have 71.43% of the males that do not smoke. So we can see here that more males, the male population in this data that we have, most of the males do not smoke. But as we can go here, we can see that 66.67% of females smoke, while we have 33.33% of them that smoke. So 66.67% of females smoke and 33.33% of the males smoke. All right. All right, so you can see here underneath the tables that we can see below, we have advanced analysis such as the odd ratio as well as the risk ratios. And if we scroll down, we also have the chi-square test results here, the analysis results. So these go into more details about the relationships between the variables. While we don't dive into these calculations, they help assess whether there is a significant connection between these two variables and how strong the connection might be. Let's just go do another one, an example of tables. We can go back to tables, our exposure variable, we select gender again. All right, let's just try something else. Let's do smoker, and then the relationship between a smoker and them experiencing a fever. All right, so let's press OK. All right, here you can see the table of smokers, see the relation between smoker and a smoker and a non-smoker, as well as the fever. So we had one non-smoker that experienced a fever and 6 of the other non-smokers experienced a fever. All right, and then we can see that the ones that are smokers, 2 of them did not experience a fever and 1 of them experienced a fever. So this shows that of the non-smokers, 33.33% of them did not experience a fever, while 66.67% of them experienced a fever. Of the non-smokers that experienced a fever, a high number experienced a fever of 85.71%, while smokers, 14.29% of them experienced a fever. All right, so next we'll go to the means analysis command. All right, so if you want to, the means of, we can wait by, let's say, the means of the age. Let's just find that. All right, so you can see here that the minimum age, which is the lowest age here, is 23, while we can see 61 is the highest age. We can see that the mean is 35.6, basically 36, the mean age. And then we can see that the median age is basically, if we round it off, is 31, and the mode is 23. All right, so let's just try 2 more. You can say if we want to find the mean of height. Okay, so we can see that the mean height is 171.7 centimeters, and the minimum height was basically 160 centimeters, while the maximum height was 182 centimeters, and our mode is 160 centimeters, while the median height is 171 centimeters. All right, so that's how we analyze our data in classic analysis. If you don't like something, change it. If you can't change it, change your attitude. Maya Angelou. Often we find ourselves stuck in places where we don't truly belong. The light within us that once beamed brightly is no more. But out of comfort, we stay, afraid of the unknown that comes with change. I encourage you to break free from the mindset of I'm okay and embrace the change that may seem challenging at first. This change is a roadmap to true fulfillment and contentment. The door of change is right in front of you. Will you be brave enough to open it?